So in this video, we will be going over double replacement reactions. So some quick steps to remember whenever writing double replacement reactions is to first identify your anions and realize that they will be switching partners. Second, you need to swap and drop the charges of the elements to determine the new neutral compound. Third, you need to determine the state of matter of the newly formed compound. To determine the state of matter, we look at our solubility rules. On the left-hand side of your solubility rules, you see that soluble compounds are found on the left-hand side. Things that make soluble compounds are alkali metals, ammonium, acetate, chlorate, nitrate, halides, and sulfate. Some exceptions to these rules are located on the right side of your chart. Some exceptions for halides are silver, mercury, and lead. If there is an exception, meaning a halide is bound with either mercury, silver, or lead, it makes it insoluble. For sulfate, the exceptions are calcium, strontium, beryllium, silver, mercury, and lead. If one of these are bound to sulfate, the compound is insoluble. If your compound does not have a rule for solubility, either soluble or an exception to make it insoluble, then you look at your disclaimer, and it says, assume all other ionic compounds are insoluble. We denote insoluble compounds with an S in parentheses and soluble compounds with an AQ in parentheses. It's important to note that soluble compounds have an AQ and insolubles have an S. Don't get the S confused for soluble. Let's go through a few practice problems. Sodium sulfate reacts with calcium chloride. So here I have my cation and my anion. My cation and my anion. Cations always go first in a compound. So I know my rules say that anions will switch partners. So sodium will bond with chlorine. Now the charge on sodium is +1. And the charge on chlorine is -1. So if I swap and drop these charges, they cancel each other out. Next, we have calcium sulfate. The charge on calcium is +2. The charge on sulfate is -2. So if I swap and drop these charges, they will remain the same. They would cancel each other out. So now I have to balance this equation. I have 2 sodiums here and 1 sodium here, so I'm going to put a 2 here. I have 1 calcium here and 1 calcium here. I have 1 sulfate here and 1 sulfate here. I have 2 chlorines here and 2 chlorines here. So now my equation is balanced. Next, I need to determine the solubility of each of these compounds. Sodium is an alkaline metal. Alkaline metals are soluble. Soluble compounds get an AQ. Calcium sulfate has sulfate here on the solubility rules. But there is an exception when it's bound with calcium. So since we have calcium sulfate, it makes the compound insoluble. So we put an S for insoluble. Next we have sodium chloride reacting with silver fluorine. So again, my anions are switching places. So I have sodium fluorine now plus silver chloride. The charge on sodium is +1. The charge on fluorine is -1. The charge on silver is, I can unswap and I see that it's +1. The charge on chlorine is -1. So if I swap and drop, each of these will cancel each other out. The state of matter for sodium fluorine is aqueous because sodium is an alkaline metal. The charge on silver chloride, the state of matter for silver chloride would be insoluble because even though silver is here, it only applies if it's bound with sulfate. So we can't use this rule. We have to go to the disclaimer. The disclaimer says that all other ionic compounds are insoluble. So now we know that sodium chloride is insoluble. So we put an S. Now I check for balancing of the equation. I have one sodium here and one sodium here. I have one chlorine here and one chlorine here. I have one silver here and one silver here. One fluorine here and one fluorine here. So my equation is balanced.